Good afternoon and welcome back to episode 7 of our code katas. Today we are going to just be doing a simple, I think we'll do a 7Q. We've only got about 20-ish minutes to stream. So we're going to pick a pretty easy one. We're going to do most completed. We've already done mumbling, shortest word. Complementary DNA. How fun. Alright. I think I'm just going to do this one. So, okay. Yep. So DNA is a chemical found in the nucleus of all cells and carries the instructions for the development and functioning of living organisms. If you want to know more, research it on Wikipedia. In DNA strings, symbols A and T are complements of each other, and C and G are complements of each other. You have function with one side of the DNA. You have function, okay? Strings except for Haskell. You need to get the other side complementary DNA. DNA strand is never empty, and there is no DNA at all. Or there is no DNA at all. Okay. Except for Haskell. Here's what Haskell does. This one's going to be in Go. Alright, so let's train on this. And as usual, we're going to cd to CodeWars, and we're going to make a directory for complementary DNA. Complementary DNA. cd to it. Okay. We'll touch our kata and kata tests and vim our kata test. Take this code. I need to create like some sort of snippet for this stuff. I'm not going to use any of that. As usual. Don't need it. Overrated. We're going to open up kata.test, or kata.go, and dump this in. Now we know we're going to have a DNA strand as a function, taking DNA as a variable in with string as the type, and it returns a string. So that makes our tests very easy. Right? So we have DNA tests, and that's equal to slice struct in we're going to have a string, and out we're going to have a string. And in our string in, we've got AAAA, and we get TTTT. Okay? And then ATTGC, TAACG, GTAT, CATA. There's really not much to this. I'm going to go ahead and throw in AAAA. You know what? Let's just do this. And then I believe it's, how do I, yeah, okay. So can I just do that on the whole line? Oh, perfect. Can I do it on multiple? Great. Okay, so we're going to handle that. Right. So first things first, we're going to say we're going to have to import strings. Import strings, because we're going to do some to lower. First thing we do is DNA is equal to strings.toLower DNA. Okay. Let's do upper. Okay. And then we're just going to return an empty string for now. And okay, so we got to have a function here, func test DNA. takes in t from testing, and then for the test, see, this is the boilerplate stuff I need to make functions for. Test in range of DNA tests. Ooh, DNA tests. We're going to say result is equal to DNA strand. We take our test.in, and then we say if result does not equal test.out, then t.error formatted from our string, maybe that, expected is string got, we'll just say got string, and then so from test.in, expected test.out, got result, all the types match, and we can test this. What's happening? Oh, I never entered tmux. Okay. All right. Okay, so now we test it. I thought I did strings, but I did not. There we go. Go test. All right. Define, describe it, expected. Oh. We want to get rid of all of this. Okay. Perfect. Now we test it. Perfect. Okay, so if DNA, okay, so for each of these, and then we'll need DNA pair is equal to an empty string, and we'll just append string append. I think we can just do plus. Let's verify that. Hello world. So we'll say var or my string is equal to this. My string is equal to my string plus a. And then we'll just print out my string. Okay, there we go. So for these are going to be runes at this point. That'll be interesting. What's the best way to iterate over a string? Go. Best way to iterate over a string in Go. Okay, they do for position char, and then you're gonna get like, okay, yeah, runes. But runes are so weird. So for index rune or char in the range of DNA, and we'll just thumped this thumped dot print line char. Modified DNA pair. Okay, fair. It's going to also be upset about me because I'm not using that yet. Okay, so yeah, those are runes. So can we just string those? Sure can. I don't really know how to handle that situation, so I don't think I can do it here either. String, no, because that's a name, right? So then I just say char is equal to string of char. Auto conversion. Can I use string char type string as type in assignment because char is already a thing? You know what? Let's just operate on chars. So slice. I mean, we're just appending. Frick it. I'm gonna do the thing. So, Go does not have switches. Do they? Oh, they do. Oh, great. Well, switch on string of char. Do we have breaks? Of course. Case. Does it tab? No. Case A. Why are you going over there? Do we open up the switch? Oh, we do. But we open it up, but they stay flat. Cool. Case A, DNA pair. Do we have plus equals in Go? Yep. DNA pair is equal to. Okay, so the rule set here. So A's are T's, T's are A's. T. Okay. Place T with A. Return DNA pair. And on line 10, we uncomment it, and we test. Okay. Expected from, no, I did that wrong. We actually expect this. Okay. There we go. So then we go to our code. We got a very minor dependency, and we run our sample tests. That is successful, and we attempt, and we handle all the edge cases. 7 queues are very easy. Okay, let's figure out what people did. Wow. Replacer, TA, and they just replace DNA. That's great. Replace DNA, complements, map of string, var and string. I wonder what that is. Oh, I think and is the string, the variable. Okay. And complements. Oh, that's neat. And then here's my solution. I mean, it wasn't literally mine, it's somebody else's. Actually, it looks like 2 people wrote the same amount of code. New DNA. I like this mapping one here. I really like that. The replacer seems heavy for some reason to me. This seems very clean. It's just like this maps to this, and that's perfect use of a map. Like A maps to T, T maps to A. I should have thought of that. And they do runes, and they do strings. And then, but they stringify. They've created a writer, a string builder. They didn't need to do that. They just operate in strings. Okay, lots of people did this. And there's this guy's. Where's mine? There we go. Yeah, DNA pair output. I mean, it's fundamentally the same thing. I went string. Oh, look, that's genius. In case it's a rune of A, give a string, and then I don't. Oh, then I don't have to import strings at all because I didn't need to do that conversion. Okay, lots of learning. Hello, hello Ezra Flag, welcome. Just completed a kata. Looking at my code now. I may have time for one more, but I might have to jet out of here pretty quick. So let's go ahead and pick up another kata. Let's go. We're going to do a real simple 8Q because I don't have a ton of time. Even or odd, which is just going to be a modulus problem. Opposite number, sum of positive, string repeat, inverse. These are really, really simple. Lost without a map. Let's check that out. Sounds fun. Given an array of integers, return a new array with each value doubled. For example, 1, 2, 3. Oh, this is just a simple map problem, but Golang does not have maps. So, like, Golang map function doesn't have it, right? Map, reduce, filter, and Go. The answer is no. Go is not a functional language. This will perform very poorly. So we're just going to have to loop it. Let's do this. Train. We're going to take this from the URL. We're going to make this directory. What I'm going to do is I'm going to touch these files, vim kata test, e kata. I'm going to take my tests, I'm going to paste them. I modify my tests. I don't like these in here. Instead, I just use the default import. Good, yeah. How far into Go are you? So far, I'm liking it quite a bit. I've got a few gotchas that I've experienced, but for the most part, it's really good. We're gonna go over here and paste this in. So this is going to be a slice of ints in and a slice of ints out. So that tells me what my tests are going to be for our double tests. Is going to be equal to a slice of struct that takes in a slice of ints and out a slice of ints. Okay. Right, so that's logical. And then in, we have a slice of int initialized with 1, 2, 3, and a slice of ints initialized with 2, 4, 6. And honestly, that's the only test case I need. I don't need any more. Yeah, so I'm just going to get rid of all these, and I'll create a function to test double. We take in t from testing, and then result is going to be equal to, what's our function name? Maps. Oh, what happened? Do I have an empty buffer? Results, so is equal to maps test.in. I am using vimgo, I believe. Let's look. Go. Yep, vimgo. Yeah, vimgo is great. It's really, really good. It creates buffers, but that kind of mess with my pattern of vim, but it's not too bad. I just delete the buffers. Alright, so for test in the range of my, let's see, double tests. This result actually goes on here. If result does not equal test.out. We're going to say t.error format from %v got %v expected %v. Okay, and then we got from test.in got result expected test.out. Okay. Okay. Let's cd up a directory, and then we'll cd into beginner lost without a map. And what we will do is go test. Cannot load package. No go. Oh, go mod init kata mapping. No, so go mod. Oh shoot! I've got an old version of Go installed right now. So wait, what was the error then? No Go files in here, lost without a map. Oh, where did I make those? Okay. pwd. Oh no! Move go or kata dot go to here. Okay, move kata test to here. Okay, go test. Slice cannot be compared to nil. Oh, What? What did I do? I don't know what I did there. We're gonna queue out of that. cd into beginning, and then vim kata e kata. Okay, there we go. Return a slice of int with nothing in it. Hey. Okay, cannot be compared to, can only be compared to null. Got it. So we need to copy. We need to reflect. So reflect. If reflect dot deep copy deep reflection dot deep copy. What is it? Golang reflect deep equal. Reflect. I don't know why I said deep copy. I knew better. Reflect dot deep equal. I might be losing my mind. Result. Test out. Oh, forget. That shouldn't have worked. Oh, it does not. It does not equal. Yes. Okay. So we just say for. We'll do a length, right? So I is equal to 0. I is less than the len of x. I increases, and then result is equal to a slice of int, and then we're just gonna append result is equal to append to result x of I times 2. and then we are going to return result. I don't think I need that. What's the complaint? Expected Boolean or range expression found simple statement. Oh. Yes, I know. Thank you. Append. Repent. Ta-da! Okay, that should be all we need. And paste that in, and we're just going to attempt it. There we go. Easy, easy peasy. That's an 8Q. Those are crazy simple. I love seeing how other people do it though. So they made an into the length. That's probably more efficient. I don't really know actually. Yeah, they forward the same, but they forward over a range, and I think that's more expensive as well. And then they appended. Oh, and you didn't need to declare a result before. Oh, and they did an implicit return, so they don't even need this return actually, I don't think. They did the same thing. Is there anyone that did it different? That's exactly what I did. It's no need for so many logs. They copied it, interesting, and then they took the index. So this is like a unnecessary O of n operation, and then you're doing O of n twice. Yeah, I mean, there's nothing clever to be had here. This is an example of exactly how you do this in Go, I suppose. Everyone's ranging. Is range less efficient than a for loop in Golang? Maybe not. Alright, that's where I'm going to end the stream right now. Go ahead and hit a follow on me. I'm going to be trying to do these more around this time, some in the morning, and then I do some late at night. And I'll just try to do them whenever I get 30 minutes to an hour to do so. So, thanks for watching, and I'll see you next time.